This is a phage model, or the results of a phage model, that are demonstrating an optimality of virulence. In this case, optimal virulence is that level of virulence that maximizes phage population growth. And this level of virulence that maximizes phage population growth varies as a function of the prevalence of hosts within the phage's environment that have not yet become phage infected. If host prevalence is high, then there will be selection for a greater level of virulence on a per host basis, such that the virus is getting into and then out of cells very quickly, because therefore its progeny viruses can be released and they can find new hosts to infect quickly. Alternatively, if there is fewer hosts present, then there is less strong selection for the viruses to get into and out of hosts quickly. And the result of that is that you have selection instead that is biased towards maximizing the amount of phage progeny that are produced per host infected. This is the economical strategy. This is the strategy that is most efficient, that provides the greatest yield in phage progeny per unit of host infected. So when the opportunities for movement of parasite progeny between hosts is not high, you don't tend to get selection for high levels of virulence. Instead, you get selection for lower virulence that has the effect of either over short periods or over long periods, maximizing the amount of progeny, parasite progeny that are produced, which has the effect of increasing the potential for there to be transmission. This is very similar to what we saw with the biofilms and the microcolonies. The idea that if a microcolony could grow to larger sizes, which they can achieve if they show cooperative behavior, then ultimately they can produce more progeny, and that may be selected for if the opportunities for those progeny to find new surfaces to colonize are low. So low levels of opportunity for progeny that might select for the production of more progeny or the production of progeny over longer periods of time will have a tendency to select for a reduced level of virulence in parasites such as these phages. And in environments where opportunities instead are high, if you can get to those opportunities fast enough, that can instead select for high levels of virulence that can result in, over the short term, much higher production of progeny, and therefore the acquisition of new hosts or new opportunities sooner. So down here we have host cell density against the optimal latent period. As the latent period goes up, basically the virulence goes down, and we're seeing a variation in what latent period is optimal, therefore what level of virulence is optimal, displayed by these phages as a function of the host cell density. And as host cell density increases, the optimal latent period decreases, meaning the virulence increases. As host cell density declines, there's less opportunities to find new hosts. You have selection for higher levels, higher latent periods, which correspond to higher burst sizes per infection and correspond to a lower level of virulence displayed by this parasite. So this is a measure of virulence. The higher the virulence equals, the lower the number. And this is a measure, the host cell density is a measure of transmission opportunity. The greater opportunity corresponds with the higher number.